Everybody, let's practice verifying solutions to ordinary differential equations. And you'll see these questions asked a couple different ways. So the first way is, are these equations a solution to the following ordinary differential equation? So this is our given differential equation right here. And then these are the two equations that we need to check to see if these are a solution to this ordinary differential equation. So take a minute and think about what you might need to do to see if this is an answer or a solution to this. Well, because we have a second derivative, first we're going to need to take derivatives of the solution of the equation that we're checking. So because we have two, we have to take it twice. So our first derivative, got a chain rule here. Derivative of cosine is negative sine. So with the chain rule, the 3 comes out. So it'll be negative 3 times sine of 3x. And then we have to take the derivative again. Derivative of sine is cosine, and we've got another chain rule. So negative 9 cosine of 3x. Then we do that because we're going to plug it into our ODE. So first we have our second derivative to check. So we have negative 9 cosine 3x plus 9. And make sure we're using parentheses here because, sometimes you're going to need to distribute. So just get in the habit of when you're plugging in equations into differential equations, just get in the habit of using parentheses. You don't really need to here, but it's just a good habit. Cosine 3x, because that's our original. Our y is our original function. And does that equal 0? Well, negative 9 cosine 3x plus 9 cosine 3x does equal 0. So you would say yes. And your professor might need you to write it out. Yes, cosine 3x is a solution to the ODE of this. So that's basically how we do it. So that's the first one. Then our second one we're trying to see is this one right here. And we're taking this function and plugging it into the same differential equation. So we got to do the same thing. Take the derivative 6x there. Second derivative is 6. So then the same thing, we plug it in. Our second derivative is 6 plus 9 times our original function, 3x squared. And does that equal 0? Well, no, it doesn't. I mean, we can do like a quadratic equation to find out that a couple of answers to that, but it needs to satisfy it for all x values. So yes, we can solve this, but it's not going to be a solution to that ordinary differential equation across all x values. So that'll be the first way that you see it. Are these equations a solution? And then another way you might see it is they'll ask you to verify whether an equation is a solution to a differential equation. So they might say, verify, so that you know that it is an answer, or it is a solution to the differential equation. So they might say like verify that let's try this one, e to the 2x plus 4x plus 1 is a solution to the differential equation or ordinary differential equation. Usually you'll just see differential equation. And then the differential equation is y prime minus 2y equals negative 8x plus 2. So in questions like this, it's kind of assumed that this is a solution, but we need to verify it by doing the same process. So here we only have one derivative, so this is our differential equation, this whole thing, and then this is the equation we're seeing if it's a solution to this differential equation. So we need to take the first derivative of this. So I'll put it over here, y prime. We have another chain rule, so 2e to the 2x and plus 4. That's our y prime. So then we plug it in, 2e to the 2x plus 4. Again, make sure you get those parentheses. We don't really need it here, but it's just good practice. Minus 2 times the original function, which is up here, e to the 2x plus 4x plus 1. And does that equal negative 8x plus 2? And then we distribute and see what comes out. Get a negative 8x, a negative 2. And does that equal negative 8x plus 2? We see we have a 2e to the 2x minus a 2e to the 2x, so that cancels. And then we have a 4 minus 2, so we do get negative 8x plus 2 equals negative 8x plus 2. So that's how we verify, that's how we prove that this equation is a solution to the differential equation. So if you're just starting out in a differential equations class, I'd suggest practicing for a couple hours your derivatives, because you're going to see them a lot, and you might not have done them since Calc 1, maybe. That was kind of my case. So it's good to review your derivatives, all your derivative rules. You're going to see product rule. You're going to see the quotient rule, not as much, but definitely practice your chain rule and your logarithms, and definitely your trig derivatives. Just find some videos to practice all your derivatives, because maybe you haven't seen it in a little while. All right, hope this helps.